next week, I'm afraid, will not be happening. In other words, I have a clash in my schedule this time next week. So this 6 o'clock class will be postponed by a week. Okay, so we're looking at worksheet 3 today. Worksheet 4 will be in 2 weeks' time then. Okay, so I put a note on Blackboard, so there's a couple of reminders on Blackboard about that. The afternoon will be as normal next Tuesday, but this 6 o'clock class will be deferred by a week, so we'll be moving everything forward by a week. So I'm sorry about that, but we will still have the same content covered by December, I can assure you of that. Okay, so today, this evening is worksheet 3. Question 2 and 3 in particular relate to this afternoon's work. Question 1 is, as you see, a little bit related to last week and also related to today, in the sense that it's about this concept of dominance, which is very important in our decisions, our inferences, in other words, implications of several parts of our analysis, especially today and also in topic 4 next week. So here I'm introducing a slightly different or additional terminology because it says mean variance efficient. Okay, so this afternoon I didn't refer to mean variance efficient, I just said efficient set or efficient portfolio or efficient frontier. So that's a terminology you may need for some of the textbooks or some things you may be reading where they might say mean variance efficient rather than just saying efficient set or efficient portfolio. So what is it referring to then? What's the mean referring to? Average, but which of our variables? Sorry? Expectation, that's right. So expectation of what? We get there?
Returns.
Of returns, yeah. Okay, so if you read mean variance efficiency, the mean it's talking about is the expected return. So the other part is more obvious perhaps, mean variance. The variance is therefore, whoops, be more careful. What's the variance? The risk. Okay, so mean variance means the return and risk. That's all. So don't be confused by that, where you may read that. Mean variance here is just referring to expected return and risk. So the question is setting up expected return and standard deviation for individual securities. So it's not thinking of portfolios in question 1. So it's more to do with last week than today, perhaps. And it's asking the question, first of all, in quite a technical way, which is to say, what is the mean variance efficient set of securities? And then secondly, I present it in a different way, the same question. Which securities would you be left with after you apply a principle of dominance? Bearing in mind that would be relating to a risk-averse investor's point of view. Yeah? So the two questions are the same question, it's just phrased differently, that's all. So which ones do you think are left then? Which ones are the efficient set here? C?
E.
C's, yes.
E.
What else? And E. Yeah. So there's 2 of them. In other words, it is a set, it's not 1. It's a set of 2, which many people have said C and fewer people have said E. So this is normally the case when this question comes up. Sorry? No, F and H are not efficient. If you plot them, F and H are dominated by either C or E. Let's look now. You know, if you compare C and F, compare C and F. So the return is higher for C and the risk is lower. Okay, so both the C dominates all the others except for E. Yeah, if you compare C and E, return goes up and risk goes up. Okay, comparing C and E. Yeah, so we can't say that C dominates E because both the return and the risk is higher for E compared to C.
But for risk, the higher will be C.
No, C and E.
C and E. Okay.
So remember, what we're looking for is which ones dominate each other. C does not dominate E. Our definition of dominance is, either for the same level of risk is a higher return, or if you like, is in the northwest direction in the diagram. If you look at C and E in the diagram, E is in the northeast, not in, So if it's in the northeast, then it's not dominated by C. Okay. So if you don't see why E is present, let's have a look at the diagram. See, some of you have already plotted it, which is a good thing. So this one is C, yeah? Agree? And then E is over here, yeah? So if you look at all of these others, which is all the ones which are not C or E, C is in the northwest direction of those, yeah? So C is dominating all of those. E is dominating this one only. But C and E, C doesn't dominate E because E's got a higher return. Okay. So normally, with this question, everybody sees the fact that C is a clear, dominant security over 6 of the others. But the thing you have to be more careful with is obviously E. Okay, so E is there because E gives more return than C. Although it's higher risk, it also gives more return. So we can't dismiss E. E is not irrational. That's absolutely right, yes. I mean, what many people would say is they prefer C, yeah? Because E is a lot more risk and a little bit more return. So that's a different point. E is not being dominated because E has got the highest return of all of them. So the asset or choice with the highest return cannot be dominated. If it's got the highest return of the choices, it can't be dominated. So many people who are focused on C, that may well be your preference. Is C looks like the best one in terms of probably what you're thinking is the ratio between return and risk. But E cannot be dominated by C, so E is still a rational choice. There's nothing wrong with choosing E, in other words. Why would you choose E? You choose E if you want to maximize return. Yeah? If that's your objective to maximize return, you'll be choosing E. So it's left to a preference between C and E. If you have to choose one of them, that's choice based on, do you want to have a good ratio of return and risk, or do you want to maximize return? Depends on the objective now. Any other question about this one? So, yes, I've said a lot of things about dominance, but it does have to be clear in your mind, because a lot of the steps we took this afternoon depend on dominance. The reasoning I gave and the conclusions we came to, many of them depend on dominance. So you do need to have it clear in your mind so that, for example, in an exam question, you might see, past exam questions might ask you, explain dominance and efficient sets, or explain dominance and the efficient frontier. You could see that kind of question on the past papers. But also, really for the whole of topic 3 and much of topic 4, it can't make sense to you unless you apply dominance. Okay. So that's something everyone needs to be sure about, that they're comfortable with. So this afternoon, the first half, or the first hour, was very much about portfolios with 2 assets. And also we came back to that at the end because we treated a risky and risk-free asset as 2 assets in the last page of your notes this afternoon. So that was very important, thinking about 2 asset portfolios. And that's what you got in question 2 here. The 2 assets, just simply numbered 1 and 2. Tells you the expected return and the standard deviation, so those are on an annual basis. And then gives you 7 portfolios to consider, while it's stating that this is a situation where the 2 assets have a perfect negative correlation coefficient of -1. So as I said this afternoon, that's a special case. What could we expect to see if we have 2 assets with a correlation of -1? What would be the special thing we might find?
The result of whole portfolio could be 0.
Yes, you can find a portfolio with a risk of 0. Yeah, that's feasible, where you've got 2 assets and a perfectly negative correlation. So if you remember this afternoon, one of the diagrams was a kink function like that, where it reaches the vertical axis. If you remember, have a look at your notes from this afternoon for that. So I didn't go over it in the lecture because we can do it from this question instead. But do you really have 7 portfolios here? How many portfolios is it really? Sorry, you haven't got the bottom. 5, okay, so it's only really 5 portfolios. So in terms of calculations, you shouldn't be doing any calculations for 2 of these. So which ones don't need any calculations? Yeah, number 1 and 7. So let's take those 2 first. Number 1, what's the return then? And standard deviation. So you're just reading it from the table, yeah? And same for number 7, okay? Where the weighting, or X as we used as a notation in the lecture, is 100% for portfolio 7 in asset number 2. All right? So for the others, numbers 2 to 6, what do you need to do? Calculate what? What's the expected return? How do you calculate it? Weighted, yeah? Okay, so the weighted average for the expected return. And then what about the standard deviations? What do you need to do? Okay, so you've got a formula in your lecture notes for the variance of a 2-asset portfolio. You can apply it directly, or as you suggested, you could actually modify the formula first. Because it's a -1, the formula can be modified. That's a secondary point, but in any case, you can just apply to equation 2 that we used this afternoon, this data into equation 2 to calculate the variance, and then take the square root to get a standard deviation, okay? So, number 2, what's the return? %18.4%. Number 3 return, 16.8. Number 4, 15.2. Number 5, 14.7. 6, 13.6. Okay? So, if you've got those written down, look down the column. What's happening? What's happening as you go down those numbers in the column for the returns? What's happening? Decrease. They're decreasing each time. Why are they decreasing each time?
هنا ندوز كل المحلول الرز
The reason is the negatively correlated. The expected return on asset 1 is more than asset 2. So when the weighted average in asset 2 is increasing, that means the total average return is decreasing.
So you started by talking about correlation, irrelevant. After that, the rest was all correct. Alright? So for the return, the correlation doesn't come into it. Okay, but the rest of what you said is perfectly correct. Alright, which is as you go down the column for returns, it decreases because you're putting more weight in asset 2, which has got a lower return of 12 compared to number 1, which is 20. Okay, so it's a weighted average, and we're putting more weight in the lower return one as we go down the table. Yeah? Linear function, weighted average. Simple. Relationship is simple. So what about the standard deviation? We said the first one is 40% because we just read it from the table. What about the second one? Wow, fewer people are answering now. 28%, okay? And number 3, 16%. Number 4, 4%. Number 5,
زيرو
0.
0. 0, okay? You might have a tiny positive amount, but it's actually just due to rounding, it's 0. Number 6, 8%, and the last one we know is 20% from the table. So look down that column now. 40, 28, 16, 4, 0, 8, 20. Does it behave the same as the return? No. Completely different now, yeah? So, as you predicted, there is a portfolio which will have no risk because we have the perfectly negative correlation.
12 صح
So in the standard deviation column, you see the diversification is going on there. We're able to manage the risk according to our choice, and therefore, to manage the risk, we manage the risk-return trade-off, if we can manage the risk. So finding number 5 at 0 standard deviation is a function only of the fact that they're perfectly negatively correlated. That's why we can get that value of 0. So, while the return is a weighted average, this is the equation from this afternoon that you would use to calculate the standard deviation. Well, variance initially, then take the square root. And you suggested you could simplify it. So yes, you could simplify it before doing the calculation if you want. Which would be that when you put a -1 as the correlation, which is to say here, well, that becomes a minus and the correlation drops out effectively, and that equation can then be simplified. Standard deviation is the absolute value of the difference between these. Okay. So in the lecture, we had a simplification for the case of rho equals plus 1, and there now is a simplification in the case of rho equals minus 1. Of course, you get the same answer, but clearly it's going to be quicker to calculate if you took that step first of simplifying the equation first of all. It's not necessary, it's just quicker. Of course, the slides will be on Blackboard, so you don't necessarily have to copy that now. So this is the completed table, and as we were saying, the return is a linear relationship. It is what we call monotonically declining. That means every time it goes down monotonically. And then the standard deviation follows a very different function. Okay? So clearly it decreases very rapidly as these weights are changing down to 0, and then increases again here. So why does it increase again here? So in 6 and 7 we put in more weight in asset number 2. Maybe we should look at the function that we have here. Sorry, from this afternoon. So this is slide number 13, so that's the third page you may have of the notes. So this is the case we have in this question too. Rho is minus 1. So if you plotted what we have in the table there, results for question 2, it's going to look something like this if you plot it, yeah? Yeah? So standard deviation decreases. Standard deviation is on the x-axis, the horizontal axis, and it reaches down to 0. So here, and then it starts to increase again to be above 0 again. So that is the function we have, what I'm calling a kinked function there for this combination we've got in question 2. So I encourage you to plot it yourself, and you see you get something very similar indeed to that. So it's important to appreciate those special cases where we have perfectly positive correlation. So we addressed that in the lecture, and now a special case of perfectly negative correlation. And apart from the fact that the expected return is a simple function, weighted average, and the standard deviation is a non-linear function, the key thing you could draw from this is the 0, that you can find that 0 risk case. Okay. Now the question might have been organized differently. Question might have been organized differently to give you the task of finding these x1 and x2 that give you the 0 here. Yeah, that would have been a different slant on the same data. So to give you the two assets, expected returns and standard deviation, and the correlation being perfectly negative, and then say find the weights, find what is x1 and x2, that will give you this 0 risk. After all, that would be the question that you would want in practice, not to list some whole set of possible examples necessarily. You might go directly to find which is the zero risk one. Yeah. So how would you do that? If you're searching, not to do these calculations, but you're searching for the weights of x1 and x2, which give you 0 here, how would you do that? Make it equal to 0, yeah? So what you want to solve is sigma p equals 0. So you can work back from that then, yeah? So, for example, you could take the bottom one, which is going to say x1 sigma 1 equals x2 sigma 2. You've still got two things unknown there. x1 and x2 are unknown. You need another equation. They sum up to 1, that's right. Many people are saying the same thing. So your second equation is x1 plus x2 equals 1. And then you can replace x1 by 1 minus x2 then. Yeah? And then you solve it x1 and x2 because you've got two equations there. Of course, you can try it, and you will get the answer of 0.3 and 0.67, because this is going to be 0.2 divided by 0.2 plus 0.4, which is the standard deviations in the table, and this one would be 0.4 divided by 0.4 plus 0.2. So, like this. So you could have a look at that. As I've just been saying, sigma 2 is 0.2, and then the sum of them is 0.6, and this one is 0.4, and the sum is 0.6. So that gives you the 0.33, 1/3, 0.67, 2/3. So same as we've got here. Okay. Many people are nodding, some people are not. Obviously what I'm doing there is suggesting the question could be turned around a different way, and clearly that's something you might think about for the exam, and looking at past papers. Similar question can be asked in a slightly different way. Even using the same data, you can possibly be given a slightly different task to do a calculation from that data. So while what I've just been talking about is not the question I set for you, hopefully it's triggering some thoughts about, okay, there's more than one way we could look at that. Of course, an exam question will not be trying to trick you about how you do it. The exam question will be very straightforward about what you need to do. But I'm just illustrating this question could have been turned a slightly different way. So you will have these slides, of course, on Blackboard, and you can have a look at what I've done there. I should pause in case you have some question about number 2. As I said before, you look at the past exams, you'll find some questions that are similar to this. Okay? Some of our worksheet questions are the same as some of the past exam paper questions. So what we're doing in these sessions is generally preparing you for section A of the exam. Okay? Oops. Now the third question then is not calculation. One of the things we drew attention to this afternoon was the total risk of an asset having two components, a market risk or systematic risk versus the unsystematic or firm-specific or unique risk. So you've got 8 cases and you only have to think, where do those risks fall into? Is it systematic or unsystematic? So all you have to do is tick the column to decide where this would be classified. So, rather tragic start. Chief executive is killed in a car accident. Unsystematic. Okay, so that's a unique problem or unique risk for that particular firm. Secondly, a strike is declared at a large manufacturing plant, so industrial action. Unsystematic, because that's plant it's suggesting is owned by one company, one manufacturer. It's not going to necessarily cause economy-wide problem on the face of what's been written there. The third one, the UK long-term interest rates increase unexpectedly.
Market risk.
Market risk, yeah. What's the important word there? Unexpected. Yeah. Okay. So, in general, when we think about risk or uncertainty, clearly an unexpected event is very different to something that was predictable, where we expect the interest rate to rise, or where you have a survey of economists and all of them say the interest rate is going to rise. So, the market will have a consensus about these changes to macroeconomic variables, and it's the surprise element that matters with regard to risk. So, number 4, a company unexpectedly wins a large contract. Unsystematic. Unsystematic. One company wins the contract. The fact that it's granted by the government is not relevant. It's one company that gains that contract. Is it good news or bad news? Good news.
Yeah, for the company.
It's risk, and it's good news. Yeah. Good news is risk. Standard deviation, dispersion. It's not about only the downside. Yeah? So we spoke about that 2 weeks ago, and maybe a bit last week as well. So some of these are bad news, and some of them are good news, but we are classifying all of them as risk. What's the word in number 4 again?
Unexpected.
Unexpectedly. Okay, so it's unexpected good news. And we still classify that as a risk. So number 5, a more restrictive monetary policy. Market risk. Congress in the US votes in favor of a large reduction in taxes.
Market risk.
Market risk. Good news or bad news? Good news. We don't like taxes. Number 7, company reveals a discovery of new oil. Unsystematic, that's for that company. Yeah. And finally, number 8, the US dollar unexpectedly declines. Market risk. Okay. So we will be expanding on that issue, systematic, unsystematic risk, in topic 4. There's one more point to mention, which is a good question I received. The risk-free rate. Okay, so it's not, question 3 now or anything. It's a general point about the risk-free rate. So I asked you this afternoon, what type of assets would we think of? And you said treasury bills. I said yes, treasury bills. But does that mean Any government's treasury bill?
Non-Greek, sir.
I apologize if there are any Greeks in the room, but he's right, not the Greece government debt, okay? So when I set it up, maybe we can just go to that page from this afternoon. So this was towards the end this afternoon, and maybe I skated over it slightly quickly this afternoon. So what it says here is there's no default risk, yeah, in the second bullet point. We did pause to say something about credit risk and default risk. So the wording is the loan is small, but its risk is small. So whatever happens, it will be repaid, meaning no default risk. So you said we can't realistically say if we buy Greek government debt, that is a risk-free asset. Okay. So which government would you like to buy the treasury bills on? US? Well, who said credit rating over here?
It depends on the credit rating for the country.
Yes, that's a major factor, the credit rating. In other words, a rating of how creditworthy the government is. In other words, an estimate of how reliable is that government in terms of will they pay all their debts on time in full. So who gives a credit rating?
Standard and Poor's.
S&P.
Okay, Moody's or Fitch or S&P would be the three rating agencies that would be considered international and most reliable. So is the US in the top ranking of credit rating? No, not from S&P anyway. Is the UK in the top category?
No.
No, definitely not, no. The US was historically, the UK was historically, since the 1970s, but not in the last 3 or 4 years. They're not in the top bracket. But nevertheless, if you buy a US Treasury bill, you can still say that, you know, you're not going to have a default if you bought a US Treasury bill. But you wouldn't say the same about a Greek debt, although things may be better than they were. So if it's not US or UK, which country would you think would be of higher creditworthiness than the
Germany?
Germany seems very conclusive. Yeah, that's correct. But maybe even Germany is not the best.
Japan.
Not China, sorry. China is higher, but it's not in the highest bracket.
Japan.
Japan is quickly falling down in creditworthiness because of its failure to deal with its debt for a long time now.
Norway?
Switzerland, good choice, Switzerland, yeah. Singapore, okay, so two of the best choices, Switzerland and Singapore. Germany. Well, the criteria to have the highest rank from the rating agencies would come from the stock of government debt. So if you like, the ratio of debt to GDP, which is extremely high in the US and Japan and the UK, and is much more reasonable in countries like Switzerland and even Germany. Yeah. Other factors may be the short-term debt as well. Generally, inflation, reserves, so many macroeconomic variables of that kind. So economic growth, the stock of debt, the budget deficit, the short-term deficit, GDP growth, reserves, those kind of variables. Well, here we're talking about a very short run. So if we talked about treasury bills, it's a money market instrument, so we don't have to worry about 5 years, because money market is how long? Maximum 1 year, so we don't have to worry what will happen in 5 years. In fact, a bill issued by government is more likely to be 3 months or even 1 month. Yeah. So yes, you're right. What will happen in the future? But if we're talking about treasury bill, we're only talking 1 month or 3 months in the future, not 5 years in the future. On the other hand, government bonds, yes, you're absolutely right. A lot can change in 5 years. And while, I listed those macroeconomic variables, you're absolutely right that political risk will also have an influence on the creditworthiness of a country. And indeed, political aspects are what makes a country different from a company, the willingness to pay. Yeah, if you have a debt, you have ability to pay, which is mainly economic issue, and you have willingness to pay, which is a more political issue. Okay, so that was a very good question I had earlier. So while it's deviated from worksheet 3, it's still hopefully beneficial discussion about the risk-free rate. So next Tuesday at 1 o'clock, it will be topic 4, which is on Blackboard. But this class will be deferred by a week, so this class will not be on next Tuesday.